Welcome to the final implementation component of the data mining course. At this point in the course, you've implemented a deep random forest technique. You've made a deep and broad exploration of the feature set. You've identified a significant set of features that relate mutations to a cancer phenotype. This is really powerful. Now we're going to go and we're going to do one more thing. We're going to do a deep mining of the association rules. I know this might seem a little scary because scalability, right? What about the explosion of feature combinations? So I'm going to suggest that you make some optimizations. These are some of the things that we do in practice when we mine association rules. I'm going to give you permission to change the threshold for a frequent item set. Previously, when we did association rule mining, I fixed the frequent threshold for item sets at 4. But I'm giving you permission. You can experiment with different settings of that. So when you initially filter the features to consider, try considering only features that cover 5 or more samples, or 6 or more samples, or maybe 7 or 8, or even 9 or 10. If you raise the threshold too high, you won't find any features, or you won't find any feature pairs or feature triplets. Then you'll know that you can relax the threshold a little bit and be a little more lenient in terms of what features and items you allow into your sets. Another optimization I'd like you to make is consider only the cancer samples. At this point, let's just focus on mining mutations that occur together in the cancer samples. Additionally, consider not relaxing, but actually tightening up your thresholds for support and confidence. So you're allowing fewer pairs, triples, quadruples, and so on. So what I want you to do is play around with the parameters as I've just described and see what are the largest item sets that occur in interesting quantities in the cancer data set. Are there any quadruples, groups of 4 mutations? Are there any groups of 5, groups of 6? Are there any groups of 10, 15, or 20? What's the largest group of mutations that co-occur in the cancer samples? Once you've completed this, I want you to do 2 more things. See if you've discovered any additional features that you hadn't already discovered with your random forest. Also, and I want you to report those features if you do. And also, I want you to see if any of the features that you found are already known to pertain to cancer. Just do a quick Google search with the names of the genes that are mutated and see if there's anything that's already known about them. We've done this in our research project, and we found a few things that are really nice confirmations that we're discovering features that are relevant to this disease. So I'm just curious to see what you find. I would expect that you would find at least one, maybe several genes that are mutated that you've pulled out from your random forest and your association rule mining, which are already known to be linked to cancer. And you might even be able to guess what kinds of cancer we're working on here, perhaps, although there are many mutations that are known to be associated with multiple cancers, and we're discovering more and more associations all the time. So you may not be able to guess, but you may be curious, and so you may be able to make an educated guess as to what are the possible types of tumors that we've been studying in this class this semester. All right, go and complete the final implementation programming project over the coming week. After that, we're going to focus on the final component of the course, which is sort of like a term paper. It's a writing component. a, 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 a project that will allow you to synthesize the things you've learned in the course and to communicate in writing that you did comprehend some of the concepts from the course. Have a great week. We're entering the home stretch now. Take care.